I have a sentence here. I want you to fill in the blank. The color of the shoe is... Solutions to equations. In this lesson, we're going to be determining if a value is a solution to an equation by substitution. So we're switching gears. We're no longer talking about expressions that do not have an equal sign, but rather equations that do have an equal sign. And we want to take some number and use a process called substitution to find out if that number is what we call a solution to the equation. So back to our shoe, which obviously the shoe is blue, right? No, not right. The shoe is red. However, I just said fill in the blank, make a sentence. It doesn't matter what word you put in there. Pretty much any descriptive thing will complete that sentence. I could say the color of the shoe is black, the color of the shoe is green, the color of the shoe is squirrel. All those words complete the sentence, but they don't necessarily make it true. So what we're going to look at is what happens with variables which can stand for any number. It's sort of like that blank that I left in this sentence. I can put any number I'd like in there. However, some choices, just as with this sentence, are better than others. I can put some numbers in that will make the equation not true, and there are other numbers I can put in that will make it true. So an equation, we said, it's a mathematical sentence which states that two expressions are just alike. It shows a relationship between two expressions. There's an expression on one side of the equal sign and an expression on the other, and they both have the same meaning, even if they look different. But just like any other language, because remember, math is a language that just because you can say it in that language doesn't necessarily make it true. We hear lies in the spoken and written word all the time. In math, you can write something that is the equivalent of a lie. This is an equation that is not true. We want to focus today on how to tell if the numbers in an equation make it true. So a variable, it's any number. It's just like that blank in the example we looked at the beginning of the lesson. Pretty much, well, almost every number, in fact, there are generally an infinite number of them that you could substitute in for the variable. That is, I could replace that blank with this number, and it would make the equation untrue. Most numbers will make an equation untrue if you substitute them in for a variable. But there are some numbers that will make it true. And those numbers are what we call solutions. So we're looking for the numbers that will fill in the blank, that variable, to make a true statement. The way we determine if it makes a true statement is through a process called substitution. We literally replace the variable with the number that we think is the solution, evaluate both expressions. Remember, there's an expression on one side of the equal sign, expression on the other, and if that value that we substituted in makes the equation true, both sides come out to be the same number, then we know that solution that we substituted in is, or that value that we substituted in rather, is a solution. So let's take a look at a couple examples here. So first I've got the equation 4x plus 7 equals 19. And I want to know if x equals 3 is a solution. So this is saying that if I fill in that blank, that variable, with 3, is this something that is true? So let's find out by substituting the 3 in for x and evaluating. So I replace that x with a 3, and every time I do this, I want to make the x disappear and replace it by the number I'm substituting in parentheses. And that reminds me that I'm supposed to multiply those two numbers. Copy down the rest of this. I can now evaluate this expression, this half of the equation on this side of the equal sign. 4 times 3 is 12. Copy down all the rest. 12 plus 7 is 19. And look what happens. When I evaluate this side, I get 19. When I evaluate this side, which is pretty easy because there's no mathematical instructions to follow over there, I get 19 as well. Because when I make this substitution, I get a true statement. 19 is in fact equal to 19. that means that x equals 3 is a solution. So I would say something to the effect of x equals 3 is a solution. And you're obviously going to have more room to write than I will, but that tells me that this thing is in fact a solution. Now there are tons of other numbers I could substitute in that aren't, and we'll see that coming up. So for example 2, I want to look at 5x plus 4 over 2, 5, and then my x, remember I'm going to substitute values in there, over 2 equals 12. And now what I'm going to do is I'm going to substitute each of these values in and see which ones are solutions. So let's start by substituting in a negative 2. If I do this, I have 5 times negative 2, which is negative 10, plus 4 is negative 6. Negative 6 divided by 2 is negative 3. Feel free to use a calculator to help you do this, and on a paper where you have more space, show each step. I don't have that luxury given the small space I'm working in, but I want you to, just as we did in the last quiz cycle, show each step. This side evaluates to negative 3, this side still evaluates to 12, and what I get is an untrue statement. Negative 3 is not the same as 12, so I can say that A is not a solution. So what I do then is I go back and I try my next one. Let's see if 3 is a solution. So I would substitute in my 3. 5 times 3 is 15. 15 plus 4 is 19. 19 divided by 2 is going to be 9.5. 9.5 is not equal to 12, so 3 is not a solution either. I've made a sentence that is untrue when I filled in that blank. Now I can try my final one, 4. 5 times 4 is 20. 20 plus 4 is 24. 24 divided by 2 is 12. And this gets me a true statement. 12 is equal to 12. And so that right there, answer choice C, is in fact a solution. So you can see that all I'm doing is replacing the x with the value that I want to check and see if it's a solution. And if I get a true statement, then I know it is in fact a solution. Now, this one right here, this requires some deep thought. Explain why the solution to the equation 5 times x equals 32 must be positive. So I've got 5 times x, I can substitute some number in there, equals 32. And what this says is that the solution, the number I substitute in right here, has to be positive, and I want to know why. Well, maybe let's see what happens if we substitute in a negative. What if I put in negative 4, let's say? I can evaluate this side. 5 times negative 4 would be negative 20, which is obviously not going to be equal to positive 32. So negative 4 is not a solution. I just pulled that negative 4 out of my head. That didn't come from anywhere in particular. I can try another number. Let's try negative 2. Well, 5 times negative 2 is negative 10, 32. Again, not equal to each other. And in fact, I could keep trying negative numbers and I would notice a pattern. Anytime I took 5 times a negative number, I'm going to get a negative answer. There is no negative number I could put in here that will give me a positive answer. So I know whatever the solution is, it must be positive if I'm going to get 32 when I evaluate this half of the expression. So this must be positive so that I can have a positive number times a positive number, yielding a positive number. So finally, to recap all of this, if I'm checking to see which is a solution of this, what I'm going to do is substitute values back into my equation. So I take the x and I replace it with whatever value I'm wanting to check and see if it's a solution. So let's start with a. If I substitute in 9, I can then evaluate this side. 3 times 9, of course, is 27. 5 plus 27 is going to equal 32, and I can see very clearly that right there I do not get a true statement. 14 is not equal to 32, so I can say that this is not a solution. I can then try the other, and again I'm substituting that value in for x, so a 3 in this case. And now I evaluate both sides. 14 is pretty easy to evaluate. There's nothing to do there. 3 times 3 is 9, and then 5 plus 9 is 14. So we could say that x equals 3 is a solution to this equation, because when I substitute it in for x, when I fill in the blank, I get a true statement.